Let us now look on few more problems on reversing the order of integration. So the first problem is to evaluate integral by reversing the order of integration. So you are given the integral 0 to 2, then y by 2 to 1 cos x square dx dy. So let us first sketch the given region. So we are given that x varies from y by 2 to 1. So x equal to y by 2 എന്ന് പറയുന്നത്. So that will be the line y equal to 2x. So that is this line, and we have x equal to 1. So that is the line. So this is the line x equal to 1. Okay. Now the point of intersection will be when x equal to 1. So you have y equal to 2. So the point of intersection is 1, 2. So this is the uh, region you have. Now we need to reverse the order. Now for reversing the order, so first we need to integrate with respect to y and then with respect to x. So for integrating first with respect to y, we need to find the limits of integration with respect to y. So for that, we will take these lines. Okay, vertical lines edukka. So the line will intersect the region above at y equal to 2x and at below at y equal to 0. And on the left and right, you will have x equal to 0 and x equal to 1. Now that will give the new limits of integration. So therefore y will be varying from, so this is y equal to 0, so y varies from y equal to 0 to y equal to 2x, and x varies from 0 to 1. So those are the new limits of integration. So we'll get integral 0 to 1, integral 0 to 2x cos x square dy dx. So upon integrating with respect to y, cos x square will be considered as constant. അപ്പോൾ നമുക്ക് cos x square y വരും. Apply limits on y from 0 to 2x. So that is going to give 2x cos x square dx. Now when you take the derivative of sin x square, derivative of sin x square is by chain rule. That will be 2x cos x square. So which is this integral. So therefore integral of 2x cos x square dx will be, so the antiderivative for this will be sin x square. So we'll get sin x square from 0 to 1. So that will be equal to sin 1 minus sin 0. Sin 0 is 0. So we'll get the value of integral to be sin 1. Now the next problem is to evaluate the integral 1 to 3, integral 0 to log x, x dy dx by reversing the order. So let us first look at the curves we have. So we are given y varies from 0 to ln x and x varies from 1 to 3. So let us sketch the curves. Now y equal to ln x, this will be the graph. It will be defined when x is greater than 0. ln of 1 0 ആയിരിക്കും. So here it will intersect and it will keep on increasing. So this is the graph of y equal to ln x. Now y varies from, so the x-axis will be y equal to 0. So the region is obtained by the region from y equal to 0 to y equal to ln x, and x varies from 1 to 3. Our point of intersection will be 3 at x equal to 3, y will be ln 3. Now we have horizontal, vertical lines here. Now for reversing the order, we need to choose the horizontal line. Ini horizontal line എടുക്കുമ്പോൾ on the left we have the curve. So we need to find the variation of x. So y equal to ln x will give x equal to e raised to y. So on the left side, the horizontal line is intersecting the curve y equal to e raised to y, and on the right side it will be intersecting the curve x equal to 3. So therefore x is varying from e raised to y to 3, and then we need to move the horizontal line above and below and look for the value of y in the region. So y is varying from 0 to ln3, so that is the uh, variation of y. So we will get integral, the integral in the reverse order as 0 to ln3, then e raised to y to 3 x. So the order will be reversed now, dx dy verum. Now upon integrating, we will get integral 0 to ln3. So integral of x will be x square by 2 from e raised to y to 3 dy. So applying the limits, you will get 1 by 2, 9 minus e raised to 2 by. Okay. So then integrate with respect to y. So we'll get 9 by 2y minus e raised to 2y. The integral e raised to 2y by 2 വരും. അപ്പോൾ e raised to 2y by 4 ആവും. Apply the limits from 0 to ln3. So at ln3 we'll get 9 by 2 ln3 minus 1 by 4 e raised to 2 ln3 minus at 0 we'll have 0 minus e raised to 0 is 1, upon 1 by 4 വരും. So that is 9 by 2 ln3 minus this will be e raised to ln 9, 3 square out. So e raised to ln 9 will be equal to 9, so we'll get 9 by 4 plus 1 by 4. So that is 9 by 2 ln3 minus 8 by 4, so which is minus 2. So that is the required value of the integral. Let us look at how to calculate area as a double integral. So we have initially seen the definition or the concept of volume as a sum. So നമ്മൾ double integral over r f of xy dA defined as limit n tends to infinity summation of f of xi yi into delta ai വരും. Where I varies from 1 to n. So here we are multiplying each, അതായത് നമ്മുടെ ആറിനെ ആണ് നമുക്ക് റീജിയൻ ആറുണ്ട്. അപ്പോൾ ആറിനെ നമ്മൾ സ്മോൾ rectangles ആയിട്ട് ഡിവൈഡ് ചെയ്യുന്നു. So the area of the rectangles will be delta ai. So when f of xi yi means when your height is equal to 1, so this will become double integral over r dA. So that will be limit n tends to infinity summation of delta. Now this summation of delta ai is going to be the area of approximately the area of r. So therefore the area of a given region can be evaluated as a double integral. So it is given by double integral over r d. So that is how we use double integrals to find the area of a given region r. So here f of xy is equal to. Let us now look at few problems on finding the area using this. So the first problem is to use a double integral to find the area of the region R enclosed by the parabola y equal to x square by 2 and the line y equal to 2x. So we need to sketch the region and identify the limits. അപ്പോൾ നമുക്ക് തന്നിരിക്കുന്ന റീജൻ അനുസരിച്ച് അല്ലെങ്കിൽ ഡി എക്സ് ഡി വൈ എടുക്കുക, അല്ലെങ്കിൽ ഡി വൈ ഡി എക്സ് എടുക്കുക. So this will be double integral over r either dy by dx or double integral over r dx dy. So this is the region. So we have y equal to x square by 2, that is portion of the parabola, and y equal to 2x. So they will be intersecting at the point. So take x square by 2 equal to 2x. So that will give x square minus 4x equal to 0. So point of intersection will be x equal to 0 and 4. Now when x is 0, y is 0. So 0, 0 is a point of intersection. And when x is equal to 4, y is equal to 8. So the next point of intersection is 4, 8. Now let me take vertical lines. So y will be varying from x square by 2 to 2x, and x will be varying from 0 to 4. Taking the order dy by dx, so we'll get integral 0 to 4 x square by 2 to 2x dy dx. So upon integrating with respect to y, we'll get integral 0 to 4 y. Apply the limits from x square by 2 to 2x. So we'll get integral 0 to 4 2x minus x square by 2 dx. Now integrate this. So you'll get x square minus x cube by 3 into 2 from 0 to 4. So that will give 16 minus 64 by 6. At 0, the limits are 0. Both the values will be 0. So this will give, so we'll get 96 minus 64 by 6. So that is 32 by 6. So the value is going to be 16 by 3. So the area of the required region will be, so therefore area of the region will be equal to 16 by 3. Now let us see one more problem. So use double integration to find the area of the plane region enclosed by the given curves. So we are given the curves y equal to sin x and y equal to cos x, and x varies from pi by 4 to pi by 2. So let us draw the graphs of sin x and cos x. So sin x ന്റെ ഗ്രാഫ് ആദ്യം വരച്ചിരിക്കുന്ന ഗ്രാഫാണ്. So this is y equal to sin x, and here you have y equal to cos x. Now we need only the region from pi by 4 to pi by 2. So this will be x equal to pi by 4, and here you have x equal to pi by 2. So this is the required region. So we need to find the area of this. Now let us take the vertical lines. So you can see that y is varying from cos x to sin x, and x is varying from pi by 4 to pi by 2. So therefore uh, the area integral will be integral pi by 4 to pi by 2 integral cos x to sin x dy dx. So upon integrating with respect to y, so we will get y itself and apply the limits from sin x to cos x to sin x. So we will get integral pi by 4 to pi by 2 sin x minus cos x dx. So the integral will be sin ന്റെ minus cos വരും, cos ന്റെ sin വരും. So minus cos minus sin from pi by 4 to pi by 2. So upon applying the limits, we will get 0 minus 1 minus minus 1 by root 2 minus 1 by root 2. So that is minus 1 plus 2 by root 2 varum. So that is root 2 minus 1. So that is the required area of the region between the given curves.